This video is on transforming the unit square. So we have find the image of the unit square, so O, A, B, C, and you can see these points here. So O is the origin, 0, 0, A is 1, 0, B is 1, 1, and C is 0, 1. Under the transformation, 0, 1 minus 1, 0. So what we can do, we can see where each of the points transform to. Let's start by doing that. So the point O, or the O dash, would be, so I'll use my matrix here. So 0, 1 minus 1, 0. Okay, and I'm going to multiply it to 0, 0. Now you can see that this is just going to be 0, 0 here, because 0 times 0, add anything times 0 here as well, will give me 0 there. And then again, 1 times 0 will give me 0, 0 times 0 will give me 0. So this is going to be 0, 0. So the point O dash is 0, 0. Now what you will notice is when we are transforming the unit square, this point always maps to the same place. Okay, so the origin always maps to the origin. Now let's try A. So A dash would be, so we've got 0, 1, minus 1, 0. And A is the point 1, 0. Okay, so let's see where that goes. So we're going to have 0 times 1 minus 1 times 0, that's 0. And we have 1 times 1, add 0 times 0, that's 1. So A dash is the point 0, 1. Let's try B dash. So using the same matrix again. Okay, so we have 0 times 1 and negative 1 times 1, so that's negative 1. And here we can have 1 times 1 is 1, add 0 times 1 is 0, so 1 add 0 is 1. So B dash is going to be minus 1, 1. And C dash, so we have 0, 1, minus 1, 0. And the point C is 0, 1. So we have minus 1 here and 0 here. Okay, so now I can plot these points. So 0 dash is just here. A dash is 0, 1, which is there. B dash is minus 1, 1. Minus 1, 1, which is there. Okay. And C dash is minus 1, 0. C dash is there. Okay, so I have a new square. Now for this course, all your transformations of the unit square will result in another square. Okay, so it will result in another square. So we have another square here. Now what transformation has this matrix performed on this unit square? So I can see that A has gone there, B has gone there, and C has gone here. Now I can see that this is going to be a rotation with the center as the origin, and it's anti-clockwise and it's 90 degrees, isn't it? So A has gone there, this B has gone there, and then the C has come here. Now I also could have looked at, because I know that the origin just maps to the origin, and we can look at A and C, okay, and that just looking at these ones and the origin is the easiest way to do this, because when we know where 3 of the points are, we know where the other point of the square should be. Now I'm just going to show you something else. So what we could have done is we could have got all of these values using this multiplication. So if I had 0, 1, minus 1, 0, and I multiplied it to 0, 0, so that's for this bit here. Then I say, let's say 1, 0 for this one, 1, 0. Then for B we're going to say 1, 1, 1, 1, and for C we're going to say 0, 1, 0, 1. Okay, now remember, when we're multiplying matrices, we do the row here times the column. Okay, and this is exactly what we did here: row times column, and then row times column. So to get the first two entries like that, I'm going to do row times column and row times column. So so this would actually give me the matrix. Okay, so it's going to be 0, 0, then 0, 1, minus 1, 1, and minus 1, 0. So this will actually give me 0, 0, and then 0, 1, minus 1, 1, and minus 1, 0. Okay, so these values are all coming from here because I'm multiplying like this, and then these values are the results. So these are the points. So what you can show is that this was the point O. So I'll write that in a different color. So this was the point O. Then I had A, B, and C, and this is O dash, A dash, B dash, and C dash. Okay, and you can try and multiply this and see if you actually get this, but I think this should make sense as it is here. Now, what we need to look at is, if we just looked at, because we know that the origin always maps to the origin, if we just looked at A and C, okay, so let's just look at A and C. Let's do that multiplication and see what we get. So let's write, so if I have 0, 1, minus 1, 0, times just the points A and C, okay, and that's this point here and that point there. So the point A was 1, 0, and the point C is 0, 1. Now, what we should notice is that this is the identity matrix. So whenever I have any matrix multiplied by the identity matrix, my answer is always going to be this answer here. So this is always going to be 0, 1, minus 1, 0. And then we can see that as well. So this was A and this was C. So let me just write that. So I have A here, we have C here. Now I should get A dash here, and I should get C dash here. So do we have that? So A dash, I have 0, 1, I have that here. And C dash is minus 1, 0, and I have that here. So now you can see, actually, when we're given the matrix and we're asked to transform the unit square, it's actually very easy, because we know the origin will just map to the origin, and the points A and C will map to the points 0, 1 and minus 1, 0, because the points A and C, they make the identity matrix when you place them like this, and then any matrix times the identity matrix is just that matrix here. Okay, and I'll show you how we're going to use that on the next example. So we have this example now. Find the image of the unit square OABC under the transformation 1, 0, 0, minus 1. Okay, so we know that the point O is going to map to the same place. So O dash is just going to be in the same place. So let's just plot that first. Okay, now let's do the multiplication. So this times A and C. Okay, so I have 1, 0, and 0 minus 1 times the point A. So A is 1, 0, and C is 0, 1. Okay, now remember, this is the identity matrix, so my answer would just be this here. So this is going to be 1, 0, 0, minus 1. Okay, so I just know this without even having to multiply these matrices. Because this is the identity matrix, I know my result is going to be this matrix here. Okay, so if I write down A here and C there, I know that this is A dash and this is C dash. Okay, so A dash, let me plot that now. So A dash here is 1, 0. So let's go to 1, 0. So A dash is 1, 0. So that just maps itself to itself. So it's going to be A dash here. And C dash is here, 0 minus 1. Okay, so 0 minus 1. 0 minus 1 is here. This is C dash here. Now I know 3 points of my square. Okay, and I know the other point must be here. So B dash must be here. Okay, and now I can draw my square here. Okay, so this is the square O dash, A dash, B dash, and C dash. Okay, and then what we can see is that this matrix here actually represents a reflection in the x-axis, because A maps here to A dash, the B maps here, and the C maps here. So it's clearly a reflection in the x-axis. And we did this without even having to multiply the matrices. We did this because we know that the origin would map to the origin, and we know that the points A and C can be written in the form of an identity matrix. And then when I multiply my transformation matrix with the identity matrix here, I know my answer is just going to be whatever my transformation matrix was there. Okay, so it's very easy to find A dash and C dash. And when I know them and I plot them, it's very easy to find B, because when I know 3 of the points of the square, I know B must be here. Okay, now last example. So we have find the transformation matrix that maps OABC to O dash, A dash, B dash, and C dash. So we have that here, and describe the geometric transformation this represents. Okay, so this is just working backwards from the similar to what we did in the last example. So I can see that the O just maps to the O dash here, so origin maps to the origin. Now remember, we only need to look at A and C, okay, and where they go. Okay, so I'm just going to write, okay, so my matrix must be, okay, it must be some numbers here. So my matrix there, my transformation matrix multiplied by, so A is 1, 0, and C is 0, 1. Okay, now I need to find this matrix, and I know that when I multiply this matrix with the identity matrix, my answer should be A dash and C dash, because this is A and this is C. So let's write that. So this is A and that's C. Okay, and my answer should be, okay, so A dash here is minus 1, 0. So minus 1, 0. And then C dash here is 0, minus 1. 0, minus 1. Okay, now what I have here, now these are A dash and C dash, and what I have here is 2 matrices multiplied, and this is my answer, and one of these matrices is the identity matrix. So this must mean that this matrix here is exactly the same as this one. So let's write that. So this must be minus 1, 0, and 0, minus 1. Okay, so what you can see is that we've found the transformation matrix that maps OABC to O dash, A dash, B dash, and C dash. So this to here. And we found this using the idea that A and C make an identity matrix, and then we know the answer when we multiply it by the transformation matrix must be A dash and C dash like this. Okay, so that, and we know that this is exactly the same as that one. Now, what does this show? Okay, this looks like it could be a rotation with the center origin and 180 degrees anti-clockwise. Also, it can be an enlargement by scale factor -1, because, and this center is the origin again, because you can see that it will go like that and like that. So there's 2 different things it can be. It can be a rotation anti-clockwise, center origin by 180 degrees, or it can be an enlargement with the center as the origin and the scale factor -1. Now, here are some questions for you to try. Okay, so some of these are a little bit different to the examples that we did. So have a go at them. This I here means the identity matrix. Okay, so this means the matrix 1, 0, 0, 1. Okay, so just remember that and answer these questions and then bring that to the lesson.